the next lesson is on direct variation. So direct variation kind of describes equations, linear equations, in a very specific way. So first, a direct variation. It basically expresses a relationship between two variables in which one is a constant multiple of the other. So what does that mean? Well, in general, when we have our slope-intercept form, y equals mx plus b. But with direct variation, b equals 0. So all we have is y equals mx. We replace the m with a k, with a constant k, and it becomes y equals kx. And k is a special, it has a special name. It's a constant of variation. It is the slope. It is the slope of a direct variation. Okay? So given an equation, we're not there yet. So if b is directly proportional to a, the equation is of the form. So let's say I have these letters b and a. Then my equation becomes y equals sorry, wrong thing. The equation becomes b equals a times k times a. And we're going to talk about what I just said, all right? So basically when we write y equals k times x, we're saying y, this translates to verbally, y is directly proportional to x. That's what it translates to. So how do we determine whether each equation represents a direct variation? If it does, find the constant of the variation or the slope. So how do we determine that? Well, we get the y by itself. Your goal here, get y by itself. And if there is no b, then it's a direct variation. Okay? So if there is no b, this will be a direct variation. So make sure you write that down. So we're going to get y by itself here. That means we're going to divide by -4 on both sides. We divide by -4 on both sides, right? And we get the equation. We end up with the equation y equals -1x over 2. So my k here, k equals -1 over 2. For the next one, we are dividing by -4 all the way across. This simplifies to algebraically y equals -1x over 2 plus 5 over 4. Because there is a b, this is not a direct variation. Not a direct variation. And I'm going to write that. Not a direct variation. There is no k. There is no k. The first one is, it is a direct variation. There's one x term, one y term, and there's no b term. For number 3, I predict, because I don't see a numbers only term, that this is going to be a direct variation. So I divide by 3 on both sides. No, I divide by 21 on both sides. And I get y equals 1 over 7. If I reduce 3 over 21, 1 over 7x. So k here is equal to 1 over 7. And since this has a k, this is a, and there's no b term, this is a direct variation. And another way of looking at not having a b term is that b equals 0. But we'll come back to that. So, moving on. So the number k is called a constant of variation. It is the slope, and this is the slope of the direct variation equation. And usually what you're doing is creating the situation where as one thing changes, so as one thing changes, it varies, the other varies. That's a confusing statement. So basically what happens is k, when we solve for k, we're creating an equation, and we're in general it's y equals k times x, right? And if I wanted to solve for k, then k would equal y divided by x. So here, if I wrote the equation, this is find the constant of variation, write the direct variation equation. So if I wrote the equation, I would have y equals k times x, or in this case, 15 equals k times 3, or 3k, right? Solve for k, and I find that k equals 5. So my equation is, I'm going to write this out, my direct variation equation is y equals 5k. So following a similar pattern, I'm going to do the same thing for an x. When x equals 6, y equals 3. First, what is the constant of variation? Then, what is the direct variation equation, right? So, y equals k times x. I know the direct variation equation in general, so I can say that 3 equals 6k. And that means that k equals 1 over 2. So my direct variation equation, I'm going to write that out. My direct variation equation is going to be y equals 1x over 2, or x over 2, okay? For the last one, we're same process. We know that y equals k times x, and since it does, then negative 4 equals negative 4k, and that means that k equals 1. K equals 1. So my direct variation equation is y equals 1x, or y equals x. Now, when we're working with word problems, I told you before, when we're working with word problems, in general, when we have, I'm going to write this over here. So when we have the verbal translation, if you can't see it, make it bigger, for y equals k times x. The verbal translation is y varies directly with x. So if I say that w varies directly with h, what I'm saying is I have the equation w equals k times h, okay? Now, this means I can solve for k. I can solve for k at this point. So what do you mean? What does this mean? So how can I do that? So this is when w is 90 and h is, let's see, 3, find k. So when W equals 90, so I'm going to rewrite that. W equals K times H, or 90 equals 3K. That means K equals 90 over 3. 90 divided by 3, which equals 13. Okay? Now, I can write my direct variation equation here. So my direct variation equation is y equals 30 times k. So that means every time, every x value gets multiplied by 30 in order to find the w value. So we're going to set up an equation for the next one. We're going to use variables, and we're going to check to see what variables we want to use here. So I'm just going to go through and highlight what we're working with. So it says wages. So wages, I'm going to call it W. Wages vary directly, so equals K times hours, or H. K times H. All right, so here's my equation. W equals K times H, or in this case, we want to solve for K. So Gemma makes $200, so she makes $200 equals 4 times K. That means K equals 200 divided by 4, which equals 50, right? So if I wanted to write my direct variation equation, y equals 50, sorry, not y, w equals 50h. That's my direct variation equation. All right, and I hope that gives you a little bit of a better understanding of what I mean here. So we're going to find k in a different way. We're going to use data. So we're going to see if a list of data is a direct variation. And the way we check is each time we're given a list of points, and the direct variations are evident by finding k for each ordered pair. So remember that k equals y divided by x. So if a list is a direct variation, all constants are the same. All k's. So all, let's change that a little bit. All constants of variation, or in this case k's, will be the same. So for the first one, negative 2.5 is my y value. K equals y divided by x. Negative 2.5 is my y value. So I'm going to divide that, go to my graphing calculator, and put it in there. And I'm pulling mine up now, so take yours out if you don't have it. So my graphing calculator is not working right now. That's okay. So I have negative 2.5. Let's clear that. 2.5 negative divided by 2. And I get negative 1.25. Okay, now for the next one I have 8.75 divided by negative 7. Let's clear that out. 8.75 divided by negative 7 is negative 1.25. So 8.75 divided by negative 7 equals negative 1.25. Okay, last one, checking. Is negative 6.25 divided by 5 equal to the same number? So let me check and make sure I did the math correctly here. So I have 6.25 divided by 5, and I get over here, once again, negative 1.25. So this is a direct variation. K equals k equals negative 1.25 for each set of ordered pairs. That means I can circle this and it's a direct variation. And my equation is y equals, the rule is negative 1.25 times x each time. So we're going to go through, and I'm going to do this next one with you, and then you'll do the last one on your own. And we're just going to check to see if this table of values expresses a direct variation. And we do that by asking ourselves. We ask ourselves to find k. And remember, k equals y divided by x. So for the first one, we're going to have for the first one, we're going to have 10.8 divided by 9, and we get 1.2, positive 1.2. Next one, 14.4 divided by 12, and we get positive 1.2. So far the k's are the same. The last one is 3.6 divided by negative 3, and we get negative 1.2. And we find that the k's are not the same, so there is no direct variation constant, and this is not a direct variation. Thus, there is no equation that accurately reflects what is going on in this table. So please do the last one on your own. Just divide y over x. Do it the same way. Use the ability to go play back to understand how to do it. Now, finding new values. Finding new values once you find the equation. So basically, we need to find k. So we're going to find k. These are the rules. We're going to solve for k if we need to. They might give us k, but if we need to, we'll solve for k. Right? But we're going to find k, then write the equation, and then use a new value. Use a value to find a new value. So what does that mean? So let's suppose that y varies directly with x. Find the new variable. So we don't have a lot of space here to use in order to do this work. So what we're going to do is come off to the side and use the space off to the side here. And I'm just going to number these problems. So this is number 1, this is number 2, and this is number 3. And we're going to create a box of knowledge regarding this information. So essentially what I'm going to do is just paste what I have here. So very similar to how we created those boxes of knowledge when we were finding the equations of lines, we're going to do that with these direct variation equations and finding new values. So in general, let's see what we have. So with x equals 60, y equals 150, write a direct variation equation. So in general, our direct variation equation looks like this. It looks like this. It's y equals k times x. So we're going to find k first. We're going to find k first, and so I'm going to write it over. Y equals k times x. That means 150 equals 60 times k. Okay, divide both sides by 60. Divide both sides by 60. Yeah. And I get 5/2 equals k, right? So in general, my direct variation equation is y equals. I'm going to write this out. Y equals 5 over 2 times x. Y equals 5 over 2 times x, because that's what k equals, right? So I need to find x. So I have y equals 5 over 2 times x. This equals. So they want me to find x when y equals 140. So this equals, so actually we don't want to write equals in there, so I'm going to erase that equals. So what I'm going to do is put a little semicolon here. Okay? So y equals 140. When y equals 140, what is x in this equation? So y equals 5 over 2 times x. Divide both sides by 5 over 2, and I get that x equals use my graphing calculator, x equals 56. Now the first time was kind of hard. We went through that kind of roughly. But it gets better, and I want you to understand that. So things you know in general, we're working with the variables x and y, write the direct variation equation in general, and we get y equals k times x. Y equals k times x. So when I'm finding k, all I'm doing is replacing y and I'm replacing x. So y equals k times x. So I'm going to type that out, and I have here 140 equals 112 times k, and k equals 140 divided by 112, excuse me, or it equals the fraction equals the fraction 5 over 4. Equals a fraction 5 over 4. Okay? So when I'm writing this equation, and I'm going to write it out, it's probably better. When I'm writing this equation, I really actually have y equals 5 over 4 times x, and I'm looking to see what I'm looking for here. I am looking for, they want me to find y when x equals 60. So I'm solving for y at this point. So y equals 5 over 4 times 60. This equals 75 when x equals 60. What about the next one? Well, in general, my direct variation equation is y equals k times x, right? We want to find k, but over here, it says a varies directly with b. So a equals b, so k times b. So in this instance, when we're finding k, the y value that we typically have is a, the x value that we typically have is b. So I'm finding k, right? But I just have different variables, so we got to be careful here. All right, and just be very strategic in what we do. So we have a equals k times b, or a is 10. When a is 10 equals 2k, so that means k equals 5. So in general, my direct variation equation for this particular one is a equals 5b, 5 times b. So we're not finding x, and we didn't find x here. We found y. We're not finding x. We're finding, they want us to find b when a equals 25. When a equals 25, okay? So writing this out, typing this out, a equals 5b, or in other words, when a is 25, so 25 equals 5b. So in order for this to be true, b would have to be 5. b is equal to 5, okay? The last thing we want to do is to graph direct variation equations. So when we're graphing direct variation equations, we know now that they have the form y equals k times x. And just in general, it just means y varies directly to x. The equation y equals k times x translates to y varies directly to x. And these lines, these direct variations, always go through a particular point. They always go through the origin. The origin or the point 0, 0. So if you have a point for any direct variation, you can graph the line. This is the only time. So graphically, if it does not go through, so direct variations, an equation is not a direct variation. An equation is not a direct variation if it is not a straight line, and it is not a direct variation if it does not go through the origin. Or 0, 0. So you're going to make a little checklist here. Okay? So is it a straight line? Is it a straight line? If it's a no, you say this is not a direct variation. Does it go through the origin? If it's a no, it's not a direct variation. Okay? So just make a little checklist here. So 0, 0, I'm going to put origin, line, straight line. Those are the things we want to see to determine whether or not this is a direct variation. So what I've done is just gone through and just kind of create a little table here. So I can just strike it off. I can just answer this automatically. So does this equation go through the origin? Here's the origin. No, it does not. This is not a direct variation. Is it a straight line? Yes. So this is not a direct variation. And I'm just going to go back and type that at the top. This is not an example of a direct variation. Now look at the next one. It does go through the origin. So yes, it is a straight line. So yes, this is a direct variation. This is a good example of a direct variation. Now look at the next one. It does go through the origin. It is not a straight line. So it is not a direct variation equation. So I'm going to type that. Not a direct variation equation. So we know the qualities, the graphic qualities of direct variation equations. You should be able to answer the last 3 problems easily. So the first one does go through the origin. It is a straight line, so this is a direct variation. The next one does go through the origin. It is not a straight line, it's a curve, so this is not a direct variation. Last one is not a direct variation because it does not go through the origin. It's a straight line, but it's not a direct variation. So graphically, they're easy to tell. So this is your classwork. I want to do number 1 with you. So in general, my direct variation equation is y equals k times x. This is solve the direct variation problems. So I'm going to find k first. I'm going to find k, right? So that means 3 equals 9k, or k equals 1 over 3. Now I want to find y when x equals 7. So when y equals k times x, or y equals 1/3, 1x. Let me write that out for you. 1/3 times x, or in this case, y equals 1/3 and x equals 7 times 7. What does y equal when x equals 7? And we get y equals 7 over 3. So make sure you do the math-based assignment on direct variations and continue through the problems in the rest of this lesson for the classwork. We can go over some of these problems. We do have homework for homework number 3 tonight, and have a good day. That's the end of